My name is Joan Palacios. Today I'm going to present a video for the FIU MS-MIS Cohort 23 program. The class is ISM 6326 for Professor Kaleem. The video that I'm going to present today is SQL Injection, How to Attack a Website. This is a brief overview of what I will be discussing. The first part I'm going to discuss is what exactly is SQL Injection. Then I'm going to discuss how does it work. I'm going to show some SQL injection statements, finding a vulnerable entry in the web application. Then I'm going to show how to prevent an attack. Then I'm going to present some advanced SQL statements. And then in the part 2 of the video will be a hands-on demonstration. Well, what is SQL injection? SQL injection is a hacking technique that passes SQL statements that query the backend database directly through a web application. An SQL injection exploit can read sensitive data from the database, modify database data, insert, update, delete, execute administrative operations on the database, such as shut down the DBMS, recover the content of a given file present on the DBMS file system, and in some cases issue commands to the operating system. Login pages, support and product request forms, feedback forms, and search pages are all susceptible to SQL injection attacks. It is the most common application layer attack used today. Well, how does it work? Take a simple login page where a legitimate user would enter his username and password combination to enter a secure area to view his personal details or upload his comments in a forum. When the legitimate user submits his details, an SQL query is generated from these details and submitted to the database for verification. If valid, the user is allowed access. In other words, the web application that controls the login page will communicate with the database through a series of planned commands so as to verify the username and password combination. On verification, the legitimate user is granted appropriate access. Through SQL injection, the hacker may input specifically crafted SQL commands with the intent of bypassing the login form barrier and seeing what lies behind it. This is only possible if the inputs are not properly sanitized and sent directly with SQL query to the database. Any platforms that require interaction with SQL is vulnerable. All an attacker needs to perform an SQL injection is a web browser, knowledge of SQL queries, and a creative guesswork to important tables and field names. Well, how does it work? Well, let's say if the user goes ahead and does an SQL injection, and in the username they put in apostrophe or 1 equals 1 dash dash, and in the password they enter anything. Well, the final query would look like this on the actual database, on the server-side database. It looked something like select star from users, where username equals an apostrophe or 1 equals 1. And in the password it would show dash dash and password equals apostrophe anything apostrophe. This is basically just creating a true statement, and this is why this works. And this shows you the same thing except with numbers. Let's say you want to do an SQL injection on something that requires numbers like a bank, where you would have to enter a bank account number and a PIN number. It would work the same way. This page just shows you the SQL injection characters that are needed to actually perform the injection. These are the ones that we will be using. And this just shows you some simple SQL injection statements. As you can see, they're all true statements. This is another page that shows some simple SQL injection statements. And finally, another page that shows some simple SQL injection statements. Well, finding a vulnerable entry in the web application. To find all the different entry points in a web application, a web browser or a fuzzer must be used. With a fuzzer, we insert different types of input into each entry point. Fuzzing is an automated software testing technique that generates and submits random or sequential data to various entry points of an application in an attempt to uncover security vulnerabilities. We use this technique to send specific string combinations with SQL-specific reserved characters and words. We are looking for an application error or changes in the application's behavior or responses due to the insertion of one or several strings. For example, the delay query will make the application respond after 10 seconds if it is vulnerable in executing our command. In this case, it would also have to be the MS SQL server. And again, by fuzzing, we insert into every one. This includes fields in web forms, script parameters in URL query strings, values stored in cookies, or hidden fields. And this is what we would enter for the character sequence, the SQL reserved words with white space delimiters, and finally the delay query. Well, how to prevent an attack? Use dynamic SQL only if it's absolutely necessary. Dynamic SQL can almost always be replaced with prepared statements, parameterized queries, or stored procedures. For instance, instead of dynamic SQL, in Java you can use prepared statement with a bind variables. In .NET you can use parameterized queries such as SQL command or OLDB command with bind variables. And in PHP you can use PDO with strongly typed parameterized queries. In addition to prepared statements, you can use stored procedures. Unlike prepared statements, stored procedures are kept in the database, but both require first to define the SQL code and then to pass parameters. Escape user input. Escaping user input is less effective than parameterized queries and stored procedures, but if parameterized queries and stored procedures can't be used, escaping user input is still more than nothing. The exact syntax for escaping user input varies depending on the database, so you need to check your DB docs for the correct syntax and examples. Assume magic quotes is always off. When the magic quotes GPC variable is off, this can prevent some but not all SQL injection attacks. Magic quotes are not an ultimate defense, and what is worse, sometimes they are off and you don't even know about it. This is why it is necessary to have code for the substitution of quotes with slashes. Install patches regularly and timely. Even if your code doesn't have SQL vulnerabilities, when the database server, the operating system, or the development tools you have vulnerabilities, this is also risky. This is why you should always install patches, especially SQL vulnerability patches, right after they become available. Remove all functionality you don't use. Database servers are complex beasts and they have much more functionality than you need. As far as security is concerned, more is not better. For instance, the XPCMD shell, extended store procedure in MS SQL, gives access to the shell, and this is just exactly what the hacker dreams of. This is why you should always disable this procedure and any other functionality which can easily be misused. Use automated test tools for SQL injections. Even if developers follow the rules above and do their best to avoid dynamic queries, with unsafe user input, you still need to have a procedure to confirm this compliance. There are automated test tools to check for SQL injections, and there is no excuse for not using them to check all your code of your database applications. One of the easiest tools, and a far more or less reliable one to use is the SQL injection, is the Firefox extension called SQL Inject Me. After you install the extension, the tool is available in the right-click context menu, as well as from the Tools to Options section. Well, now I'm going to show you some more advanced SQL statements, grabbing username and password. With this query, all the logins and password from the user's tables are extracted into a variable called @var. This variable @var is inserted into a new table called temp in a column called var. The var column on the temp table is then sent back through an error message. The temp table is deleted from the database. We could also insert a login and password of our own into the user's table with the following command. Let's say you can also insert into user select, let's say for Michael Smith, and then Michael, and pass 123. And this just shows you how to create a database account on 5 different databases with MS SQL, MySQL, Access, Postgres, and Oracle. This will show you how to do brute forcing passwords. Passwords can be brute forced by using the attack server to do the processing, and you would use this script, this SQL crack script. The hashes could be broken offline, but if we wanted to use the victim server processing power to brute force the password hashes, we can use the above query to start a dictionary attack on the stored hashes. The dictionary could be inserted by hand, with a Perl script, or by sending a word list. Transferring data. Once the structure has been recreated, the data may be easily transferred a table at a time. Using this method, an attacker can retrieve the contents of a table even if the application is designed to conceal error messages or invalid query results. This is the end of video presentation 1. The next video will show a hands-on demonstration of SQL injections, both easy and more advanced SQL injection techniques. Thank you for watching.